Hello everyone. In previous video lecture we have studied what is dynamic memory allocation and the Malloc method. In this video lecture, it is a series. In this video lecture we are going to study about the Calloc method of dynamic memory allocation. So as you know that dynamic memory allocation allocate the memory at the run time. So we take that much of memory that we needed, right? No extra memory, no lack of memory, right? So if you go for this Calloc stands for the contiguous allocation, right? It's a contiguous memory allocation. Malloc stands for memory allocation only, and Calloc stands for contiguous allocation. Now Calloc will allocate the specified number of blocks of memory of the specified type. That means what? In Malloc, if you see, Malloc will provide only one block of memory of your needed size, right? You can say in a previous example we have seen that 400 bytes, right? So 400 byte, it will provide only one block of 400 byte, right? Now if you consider Calloc, it will give number of bytes. That means not only one block, it will provide us a number of block. That number we have to choose, right? Suppose I am choosing 4, so 4 number of block of a specified size. If I want a 4 block of 100 size, I can do that, right? So there is a difference between Malloc and Calloc, that Calloc will provide number of blocks for a memory location, while Malloc will provide only a one block of a specified memory location. Now in the syntax there is a little bit difference, right? Other things are same. So PTR, that is again pointer, right? You can take any variable name over here, right? It will return a pointer of a void data type, so we need to typecast, so that's why I have written cast type star Calloc. And here previously in Malloc we are having only one parameter to be passed, right? But in a Calloc I need to pass two parameters. First, that is number of blocks, right? And that is the number of blocks, and the second element, that is size of my blocks. While in Malloc I'll directly apply size of element, because it provide only one block of a given size, and here I am having number of elements, number of block of a given size, right? So that's why previously for that I have applied n into size of. Why in n into size of integer? Because I want 4 byte of data multiply with 100. At previous example n was 100, so 100 into 4, that is 400, right? But here if I want like that, then I just need to write that is 100 comma size of integer, right? Then also it will provide the same amount of data, but the difference is that here it will provide 100 blocks of the byte 4, right? And this will provide 400 byte of data of only single block, right? So what I need to write, PTR integer star Calloc. Here just another example, 25 into size of integer that is 4, so it will provide 25 block, right? This is first block, second block, third block, up to 25 block of 4 byte of data. Clear? So I hope you understood this Calloc method. So let us take one example. So here I am having a program. First I am having the header files, and as you know that I need to include this stdlib.h because we are doing the dynamic memory allocation. Again here we are having initialization of variables ni, that is my normal variable, and this is my pointer, that's why it have written star, so star PTR. Then here I am assigning a value n is equal to 5. As I told you previously that if you want that from the user, you can use printf and scanf. You can tell the user to enter the data and you can store it ampersand n, right? Now here there is a difference in this statement only, that ptr here instead of malloc I am doing the memory allocation using calloc, right? So ptr, that is pointer, is equal to integer star calloc n comma size of integer, right? If you want the memory, if you want a pointer of a float data type, you just need to replace this size of float, and here you need to typecast it with a float, right? That much difference only. If I want a data of a character, so I can here write here ch star and size of character, right? char, right? Again what I am doing, I am checking if ptr is equal to null. If it might be possible that some error might be there, then your ptr will be null. So if ptr is equal to null, then it will give a message that memory not allocated, and it will return from here only. If it is not like that, then it will go for the adding of data, right? So printf enter the element, just a message for the user, printf enter element. Then I'm applying a for loop for I is equal to 0, I less than n, I plus plus. These things are similar as we have in our previous example, right? I'm scanning the data percentage d ptr plus I, that means whatever memory location is given to this value, plus I, that means first it will be 0, then it will be 1, that 2, 3 and 4. So this would be added to your value of ptr, right? So ptr plus 0, ptr plus 1, ptr plus 2, ptr plus 3 and ptr plus 4, right? Again I'm repeating this here. I need not write ampersand, need not to write ampersand, right? Because ampersand gives the address, and if I am having a normal variable, so we write ampersand a, so it will provide the address of this a, right? But here ptr itself a address because it's a pointer, right? Here we are using the concept of pointer, right? So ptr itself a address, and if I want to print the value, so I need to write star ptr, that is the value of that particular location, right? So ptr plus I scanf percentage d ptr plus I. Then again I'm printing here the data whatever I have stored that I want to print. So I'm writing printf percentage d. Here I am writing star because star gives the value of that particular location, right? If you want, you can apply another for loop and you can print in that also, right? And then free ptr. Why this free ptr is needed? Because to deallocate the memory, we have already allocated the memory of that particular given size, but now at the end of the program, after the completion of program, I need to deallocate the memory. So for deallocation I'm using this free, right? And then get ch, right? So if you execute this program, you will store some of the data, right? And then you will print that data, right? Now you can do one more thing as for your practice, that you can store the data and you can print the sum of that data, right? You can apply the formula for summation, right? You can sum, take one variable, sum is equal to 0, and you can add up that numbers one by one in that sum variable, and at the last you can print that sum, right? So you can try that. You can try different things with this dynamic memory allocation, right? So I hope you understand this Calloc. Now next what we are having, that is Realloc, right? Reallocation method, right? Realloc stands for reallocation method. Now why it is used? It is not used for allocation of memory. It is used to change what memory allocation I have already done, right? So it will dynamically change the memory allocation of the previously allocated memory. So if I have used malloc or a calloc and I have allocated some memory to PTR, and if I want to change the size, right, because if the size is insufficient, right, if the memory previously allocated with the help of malloc or calloc is insufficient, then realloc can be used to dynamically reallocate the memory. So what we are doing over here, that we are reallocating the memory, right? So what is the syntax for that? Here there is no need for typecast. Simply you need to write realloc in a bracket PTR, that is your pointer name, the variable name that you are using, right? So it can be if you are using ABC, so here you need to write A or B or C, right? Previously I have used PTR, so I am writing PTR over here, and then I have to mention the new size, right? What is this whatever size I want to allocate now, that I need to write it over here, right? And again I'm storing it in a PTR itself, right? This is my pointer and I'm storing it in the same pointer, right? So we'll just take a look at the example. So again I'm having this hash include stdio.h, hash include stdlib.h, that are my header files, right? Here I am having variables. This is my pointer, that's why it is written as a star PTR. I, n1, n2, I am having two variables, n1 and n2, right? Now first what I am doing, printf enter the size, right? I'm taking the size from the user and storing it at n1, right? That's why it is written as ampersand n1 here. N1 is my normal variable, so I need to write ampersand to scan the data, because ampersand shows the address, right? Now what I'm doing, I'm assigning a memory using malloc method. Here I'm using a malloc method, right? You can use calloc as well, right? So malloc, I want that pointer of integer, so integer star typecasting malloc n1 into size of integer, right? I'm using malloc, that's why I have written, I multiplied this data with n1, because in a malloc I can have only one parameter. If you want, you can use calloc. So for calloc you need to write n1 comma size of integer, right? That is the difference between malloc and calloc, right? And I'm storing it in a PTR, right? Now what I'm doing here, I'm printing the locations only. I'm not storing the data, I'm not entering the data for your concern. I'm just printing the memory address, right? So printf addresses of the previously allocated memory, right? Whatever memory is allocated, it will print the address of that. So for that what I'm doing, I is equal to 0, I less than n1, I plus plus, right? And here I'm writing printf %p, that is used to display the address in a hexadecimal form, right? So that's why I have written %p, and here I am having ptr plus I. Here I am not writing star ptr plus I, because if you write star ptr plus I, it will return the value, and we have not stored any value here, so it will give you garbage data. But what I am writing ptr plus I, that means itself a address, whatever memory is allocated to your program, that address of that memory is printed over here, right? Now what I am doing, I'm taking the new size from the user. So printf enter the new size, right? Scanf %d ampersand n2, that new size is stored in my another variable, that is n2, right? Then here I am reallocating, that means I am changing the size from n1 to n2. It might be possible previously I have given 5 and now I am going to give 10, right? So I am changing the size of this. So for that I am using ptr realloc. Again ptr, because here my pointer is ptr, so ptr and newly allocated size. So new size, that is n2 into size of integer. Previously it was n1 into size of integer. Here I am writing n2 into size of integer, that is my new size, right? Now what I'm doing, I'm just printing that data, right? Again, I'm printing the address only, right? So you will get to know what is the difference between these two, right? So printf addresses of newly allocated memory. I'm using the for loop, I is equal to 0, I less than n2, I plus plus, and here again I'm printing the address in the hexadecimal form. So printf %p/n ptr plus I, that will print the address. So if you give n1 is equal to 5, it will take 5 addresses, it will print 5 addresses, and if you apply n2 is equal to 10, it will print newly allocated 10 locations, 10 addresses of the data, right? And then at the end I'm freeing up, deallocating the memory, and get ch, and bracket is over, right? You can try this practical and you can see the difference, how it will work, right? How reallocation is done, how memory allocation malloc is done, memory allocation with the calloc is done, right? You can try different examples. Open your turbo C, write down this program, and see the result, right? So I hope you all understand this concept of dynamic memory allocation. In this we are having ultimately we are having 4 commands, right? Basically 3, but ultimately we are having 4 commands. First, that is malloc, memory allocation. Second, that is a calloc, contiguous memory allocation, contiguous allocation. Third, we are having realloc, that is reallocation of memory. And last but most important, that is free, because we need to deallocate the memory, right? So that is free. So I hope you all understand this. Thank you very much.